pulse in between them.
Very, very cool. Very, very cool. Okay. Yes, Tess.
I went sledding at Mason Rice yesterday.
At where?
Mason Rice.
Mason Rice. Is that another school? Cool. Why do you think schools have the best hills? Why do you think that is? I mean, it's something we should think about. Like, why do they build schools on really cool hills? Just something to think about. Now, why don't you guys look at page 1 in your packet? And I want to talk to you about a couple of words that are really important for today. So we're doing an area of mathematics called combinatorics. Can you guys say that word out loud?
Combinatorics.
That's right. Oh, hi, Roman. How you doing, buddy? And I'm going to change your name so I don't call you Jack because it says Jack right now, and I do that a lot. So I'm going to change your name to Roman. Thank you there. And Roman, if you have, we're talking about something called combinatorics. Combinatorics is really, believe it or not, the study of mathematical counting. Now, remember how we were doing the exercise last week, and if we had 2 squares and they had to add up to 3, well, we would know that the squares would have to be what or what?
2, 1, or 1 and 2.
Right. But what's interesting is in a permutation, the order really matters. So 1 and 2 is different from 2 and 1. Whereas in a combination, 1 plus 2 would be the only combination. So for the number 3, 1 plus 2 is the only combination, whereas 1 plus 2 and 2 plus 1 are the 2 permutations. There are 2. What if, and let me just see here, I can't see Tess anymore, but what if we had 3 boxes? And let's say we wanted to make a 6. What are the only numbers from 1 to 9 that can be used to add up to 6? Go ahead, Tess.
1, 2, and 3.
That's right. We could have either a 1, a 2, or a 3. Now, who can tell me how many different ways 1, 2, and 3 could go in these spaces? Do you want to take a guess, Jeremy or Aaron or Sabrina? Because I know that Brennan and Tess have an idea. What about you, Roman? Oh, hello. So who is that that's joining us? So who is joining us right now?
This is Avery. Hi.
Can you spell it, please?
Avery.
Avery, how you doing, man? This is Mathletes. I'm Mr. Kramer, and I'm changing your name to your name. And we have Roman, and we have Jeremy, and we have Brennan, and we have Aaron, we have Sabrina, and we have Tess. Everybody say hello to Avery.
Hi, Avery.
How you doing, buddy? And I am Mr. Kramer. So Avery, I'm not sure that you were able to print out the document. So could you please get a pencil and paper so you can
Yes.
follow along with what we're doing? Okay. And Avery, are you a friend of Brennan's?
Yeah, I know Brennan.
Cool. Cool. Awesome. Awesome. Well, we are all really, really good friends, and we're going to welcome you to our group. Now, Avery, we're looking at 3 squares, and our job is to have a sum of 6. That means that in this case, Tess told us that the only way to make 6 with 3 different numbers is by adding 1 plus 2 plus 3.
Plus
Do you
3.
agree?
1 plus 2.
Yes.
Because if we use 2 plus 2 plus 2, then they would not be different numbers. They would be 3 of the same numbers. So we're only allowed to use different numbers in this particular exercise. Now, let's write down 1, 2, 3 like this. What we want to do here is we want to come up with all the different permutations. Everybody say that.
Permutations.
Of the numbers 1, 2, and 3. So for instance, the next one would be 1, and then it has to be
3.
different. 3 and
3.
2.
And 2.
exactly. Now, who can come up with the logical next one? And there's no wrong answer, but there are better answers than others where we can keep ourselves organized. Who can come up with the next one? Brennan?
2, 3, and 1.
You know, I like 2, but do you notice how we went 2 and 3 in order?
Yeah.
So
Okay.
what would you do in order?
So,
So 2,
um,
anybody else can help.
1 and 3.
1 and 3. Now, Avery, do you want to try the next one?
I guess so. Yeah.
So 2, 1. If the first one was 1, 2, 3, and the second one was 1, 3, 2, we just switched the 3 and the 2. If this one is 2, 1, 3, the next one is going to be 2,
3, 1.
3,
Yes.
1.
And Sabrina, you give me the next one. It has to start with a what?
A 3.
And followed by what 2 numbers? And Aaron, you're going to do the last one.
3. I don't really know what the next
Well,
number
remember,
is.
they've got to be in order, just like we did in order, from lowest to highest. The only other numbers that are left are the 2 and the 1 and the 2. So which one are we going to do?
2 and then
Oh.
1.
But remember, if we do them from lowest to highest, it would be Aaron. 3, Aaron.
1, 2.
Exactly. And Jeremy,
next
what's the
one,
last one?
3, 2, 1.
And 3, 2, 1. And guys, how many different ways were we able to put 3 numbers in 3 boxes? Say it out loud.
6.
Now, I have a little surprise for you. Would you guys like to see a surprise?
Yes.
All right, here we go. Now, this is cool. Not a lot of kids know how to do this. Are you ready? If you took the numbers 1, 2, and 3, and you multiplied them, 1 times 2. Who knows what is 1 times 2? Say it, Avery.
2.
2. And who knows what is 2 times 3? Go, say it.
6.
Guess what? Wouldn't that have been a little easier?
Yeah.
Oh my gosh. Now, guys, you know what we're going to do next. Next, we are going to look at 4 squares that will add up to 10. Who can tell me the only way to add 4 numbers to get to 10 where the numbers all have to be different? Oh, and by the way, Avery, in this exercise, we are only using the numbers 1 through 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I want to see who thinks they've got this. Brennan, you tested the last one. Brennan, why don't you do this one?
3 plus 2 plus 4 plus 1.
And if we're doing combinatorics, don't we want to do it in order?
Yes.
So therefore,
4 plus 3 plus 2 plus 1.
and in order from lowest to highest?
1 plus 2 plus, 1 plus 2 plus 3 plus 4.
And does anybody agree with that?
Yes.
Yes, yes. And Aaron, what do you have to say, buddy? Aaron, you raised your hand, bud. What's up? You have a question? Oh, I think, yeah, oh, you're just saying yes. I think he was just saying yes. Now, guys, how many different ways can we put the numbers 1, 2, 3, and 4 in 4 boxes? Avery, what do you think?
2, 1, 3, 4.
Well, it's interesting. Let's start with 1, 2, 3, 4. And then let's remember, we always want to start in order. And then let's keep the 1, let's keep the 2. But Roman, what am I going to do with the other 2?
Switch them.
To what?
To 3.
Well, we already have a 3, so we want to switch them to
A 4.
a 4 and a 3. Now, in the next one, who knows the next one? We're going to keep the 1, but we're going to have to change the 2. Roman, what do you think?
4.
Well, if you go in order, the next number is
3.
yes. And then in order, go.
2 and 4.
Yes. And the next one is 1, 3, what?
2. Or 2.
Say it out loud.
4, 2.
4, 2. Now, here's the bonus question. Who thinks they have the next one? Don't say it out loud. You can write it down, see if it makes sense. I'm actually going to ask Jeremy for this one, and Jeremy's going to say it nice and slowly. Go ahead, Jeremy.
2, 1, 3, 4.
Remember, we're always starting with 1 here.
1, 4, 2, 3.
Oh my gosh. Jeremy, that was beautiful. Sabrina, can you follow it up, please, with the last one in this group?
1, 2,
Remember? 2, 2, 3, 3.
4.
Right. Oh, hey,
3.
Raymond. How you doing, buddy?
Can you explain it again now? I was a little bit late.
2.
I couldn't hear you, buddy.
Can you explain it again? I was a little bit late.
Yes, yes. So by the way, Raymond, I want to introduce you to a new friend of mine named Avery. Avery, say hello to Raymond. Raymond is part of our mathlete group. It came a little late. And Raymond, what we're doing is we're looking at the only way to make 10 with 4 different numbers was 1 plus 2 plus 3 plus 4. And then we're looking at how many different, what's the word, guys? Permutations. And we found that we could do 6 permutations with 3 numbers. But with 4 numbers, guys, haven't we already got 6 permutations here?
Yes.
Now, who thinks they know what's going to happen next? Because every one of these has started with a 1. What happens when we start with a 2? How many permutations will we have when we start with a 2?
6.
And how many permutations when we start with a 3?
6.
And with a 4?
6.
6.
Now, how many people here know what happens when you have 4 6s? Don't say it out loud. 6 times 4 or 4 times 6, or you can actually add 6 plus 6 plus 6 plus 6, or 4 6 times on 3. 1, 2, 3.
24.
24.
Well, guess what, guys? There are 24 permutations with 4 numbers. Now, wait a minute. Couldn't we just, guys, look at this. Couldn't we just have done 1 times 2? Who knows 1 times 2? Say it.
2.
2 times 3
6. 6.
and 6 times 4
24.
equals 24. So guess what, guys? If I said to you now that we had 5 boxes and we had to fill them with 5 different numbers, 1, 2, 3, 4, and 5. By the way, what would that add up to? Don't say it out loud. Raise your hand if you know the sum of 1 plus 2 plus 3 plus 4 plus 5 on 3. 1, 2, 3.
15.
That is correct. Now, let's think about this. Would you like to write down all of the permutations, or can we just take 1 times 2 times 3 times 4, which we know equals what?
24.
94.
And couldn't we just do 24 times 5? And I want to talk about 24 times 5 for just a minute. If you know it, please don't say it out loud. We could always do repeated addition, and we could add the 4s, carry to the 10s, and then add the 10s. The other thing we could do is we could take 5 and we could multiply it by 24, but in a different way. Who knows how to split up 24 into 2 really easy numbers to work with? The easiest way to split up 24. There are a lot of ways to split it up, but I'm thinking of something that's easy. Sabrina,
12.
you mean
Like split
12
up
and
the
12?
Yeah.
You mean 12 plus 12?
Yeah.
And Sabrina, that was beautiful. If you did that, it would work. I'm also thinking of something maybe a little easier because it's not easy to multiply 12 times 5. Who knows another way to split up 24 into two numbers? I love your 12 plus 12. Jeremy?
13, 11.
That's a good one, but that's even more difficult. I want to go with easy, Jeremy. Like, you know what you could also say, Jeremy? You could also say 19 and a half and 4.5. But that wouldn't be easy. Aaron?
14 and 10.
Oh, I like it. You're getting warmer. Raymond, what about you? Something even easier. And Raymond, why don't you come? Oh, Raymond got it, guys. 20 plus 4. So everybody knows 5 times 20. Do you guys know 5 times 20? It's a lot of fun. On 3, 1, 2, 3.
100.
100.
And then we have to add, what's 5 times 4? Let's do it.
20.
5, 10, 15,
20.
20. And when we add
120.
100 to 20, what do we get?
120.
Now, do you know, Sabrina, that if we had done 5 times 12, 60, and 5 times 12, 60, that we would have also gotten 120. But it may just have been a little bit harder. We also could add 4 plus 4 plus 4 plus 4 plus 4 is what? Go.
6.
Go ahead, Roman. 5 4s make what, Roman? Give it a shot. Even if it's wrong, we'll get some help. Go ahead, buddy.
54.
Well, 54 is 50 plus 4. This is 5 4. So we can go 5, 10, 15,
40.
15.
16.
Okay, let's do it again, everybody. 5, 10, 15,
20.
20. So we put a 0 from the 20 and we carry the 2. Who knows how to count by 2s? Let's do it. 2.
4, 6, 8,
And there we are. 2, 4, 6, 8, 10, 12. And what do we get?
120.
So guess what, guys? We would have 120 different ways. Now, this question we are not going to do, but I want to open it up anyway to the group. If we were looking at one of our crazy puzzles, and I'm going to go to what I call the insane kakuru. And, oh, this is not the one that I was thinking about. I was actually thinking about one where we would have 9 boxes. And the only way to make, oh, there we go. And the only way to make 9 boxes Now let's see if anyone can think about how we might add the numbers 1 through 9. And don't say it out loud if you know it. Just think about it. Think about a really cool way. and write it down and test it if you think you know it. And I'm going to make some funny brackets here because I like to connect numbers. All right. Who can tell me what 9 plus 1 is?
10.
10.
Who can tell me what 2 plus 8 is?
10.
Who can tell me what 3 plus 7 is?
10.
Who can tell me what 4 plus 6 is?
10.
Who can tell me what 10, 10, 10, 10, and 5 make?
45.
And guess what, guys? If we had to fill 9 squares to make 45, do you know how many permutations we would have?
No.
Now, we're not going to do this one because it's a little bit beyond our level right now. But I will tell you, it's a very cool number. And this number would be the answer to 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9. And you wouldn't believe how big it is. Avery, do you have an idea how crazy big that number would be?
Like 100? No. 59. No.
Way bigger. Way bigger. Way bigger. Who's got some other ideas?
91.
91. What about you, Tess? Oh, Tess, you're muted, sweetheart.
700.
700. That's a lot, but that's not even near as many as we need. Brennan?
Over 1,000.
I agree, but we need to go even higher. Come on, Jeremy. Come on, Aaron. Come on, Raymond. Come on, Roman.
1000.
Well, 1,000 is exactly 1,000, and it's even higher than that. Sabrina, what do you think?
2,000.
Awesome. Keep going. Avery.
Oh,
10,000.
100. Add to the 100.
Wait. 10,000. Roman said 100,000. It's higher than that. Tess?
No, add to the 100.
300,000.
Guess what, guy? Brennan, what do you think?
1 million?
Not 1 million. Aaron?
Trillion?
Wait, I couldn't hear Aaron.
9 trillion?
No, that's too much. Jeremy, remember it's under 1 million. Roman?
A trillion?
Roman, I can't even count that high. That was awesome, but no, that's too high. Jeremy?
Oh.
Maybe it's 4,030.
Okay, the person that came the closest, I think, was somebody said 300,000. I think it was Tess. It's 362,880 permutations. It would, do you know that would take us, you would be as old as Mr. Kramer if you try to come up with every solution for that. So we are not going to be doing that today. So the next thing I want to talk about is this. I want you guys to look at the numbers that we have right here on page 4.
Hey, Mama.
I know, Avery, that you don't have that, so you'll just have to follow along with what we have.
What time?
Last week, when we had sets of 2, so we had 2 boxes. If we had a clue of 3, which means that the two boxes could equal 3, we would say that the boxes would contain a 1 and a 2 or a
2 and a 1.
2 and a 1. And if the clue was a 4, we weren't allowed, and Avery, this is an important rule, we weren't allowed to have the same numbers. So we could not have a 2 and a 2. For 4, we would have to have a what?
One and a 3.
Or
4, 3 and a 1.
a 3 and a 1. Now, those were the two easiest. The other two that were equally easy was 16 and 17. If we had two numbers that equaled 16, we could only have what?
9 and 7.
Or 7 and 9.
9.
And if we had a clue of 17, we would only have
9 and 8.
9 and 8 or 8
Or
and 9. Now, the question that I have for you for this week, we want to search for the most permutations, the most combinations on a Kakuru board. Now, let's think about the numbers. The numbers 3 and 4 are here. The numbers 16 and 17. And in between, we have the numbers 5 through 15. What do you think would be the clue with the largest numbers of combinations of two numbers? Look at the numbers. You know the smallest was 3 and 4 and 16 and 17. So we can't use those. And we don't want to because they're the smallest. We want the most. What number do you think would be the best clue? And that would have the most. You would not want to do this during Kakuru because it makes it way harder. Go ahead, Roman.
15.
Well, 15 is a good one, but let's look at 15. If we only have two boxes that can make 15, let's think about how many options. 9 and what?
6. 6 and 9.
Or 6 and 9. What about 8?
8, 7, 7,
Or
and
7 and 8. Now that makes 15. Now, guess what? Roman is right. 4 is way more than 2. These only have two options. 15 has 4. But where do I want to be looking on this list? Do I want to be looking at the numbers near 16 and 17? The numbers near 3 and 4? Or the numbers that are more towards the middle?
More
Jeremy?
towards the middle.
Jeremy, what do you think?
10.
Ah, now we're talking. What numbers do you also think we should try?
12.
Well, if you choose a 10 because that's the middle number, Brennan,
I was thinking 7.
yeah, but that's kind of closer to 3 and 4. Just like 15 was closer to 16 and 17.
9.
And I can't, yeah, and Tess and Raymond, I can't see you, so I don't know if you're raising your hand. I would agree, and Avery?
I was just yawning.
Okay, and do you guys have another one? If 10 is the center number, and we're gonna test 9, shouldn't we also test?
11.
11.
All right, let's do it, guys. Go to a separate piece of paper. We want two numbers that add up to 10. Let's do all the different permutations. Go. Let's start with 1.
9 and 1.
1 and 9 or 9 and 1? Go.
8 and 2. 2
and
2 and 8.
Go.
7 and 3.
3 or
3 and 7.
Now, guys, if we're starting with low to high, 1 and 9 or 9 and 1, 2 and 8 or 8 and 2, 3 and 7 or 7 and 3.
3.
And go.
6 and 4.
No.
4 and 6 or 6 and 4.
4 and 6.
And which one are we
5
not
and 5
allowed
or
to do?
5 and 5.
We're not allowed to do 5 and 5. So how many different permutations did we come up with the number 10?
8.
That's right. There were 8. Now, what do you think we get for the number 9? Let's do it. Go.
7.
1 and
8.
8.
Or 8 and 1.
1.
7 and
2
7
and
2 and 7.
7 and 2.
3 and 6. 6
or
and
3.
4 and 5. 5 and 4.
5 and 4.
Guess what, guys? Same thing. How many solutions?
8.
8.
Now let's do 11. Go.
9 and 2 or 2 and 1.
So let's do 9
2
and
or 2 and 9.
or 2 and 9. Oh, by the way, why didn't you choose the number 1?
Because
1 and 10.
Yeah, but we don't have a 10. We only have the numbers 1 through 9. Now let's do the next one. 8 and
4
And
or
3.
4 and
3 and
8
8.
and 3 or 3
3
and
and
8. Roman, you
8.
really should be paying attention to this.
7
Okay.
and 4. 4 and 7.
Keep going.
6 and 5. 5 and 6.
6.
How many, guys?
8. 5.
8.
So guess what? The worst numbers for us to choose on a Kakuru board with a set of 2 would be the 11, the 9, and the 10, because they have too many options. We want to choose ones that have the fewest options. But what happens if we decided that we were going to choose a set of 3 numbers? A set of 3 numbers. We would have, are you ready for this? The numbers 6 and 7, 23 and 24 are the numbers that have the fewest different ways. So I'm going to write that down for you. 6, 7, 23, and 24. Now, what are the 3 numbers that add up to 6? The only way to make a 6. Go.
1, 2.
1, 2, and 3. 3, 2, and 1.
1, 2, and 3. And remember, guys, there's going to be 6 ways to do that. Okay, we've already determined that. Who wants to take on 7? Let's go, Aaron.
1, 2, 4.
Ooh, nice. That's the only way to make 7, and there will be 6 different ways to put it down. Who's going to take 23? And Raymond, I can't see your video, so if you raise your hand, I'm not going to know it. So if you could show your video, that would be awesome. Raymond, okay, gotcha. Who thinks they have an idea on 23? And if I were you, I would start with the biggest numbers. Go ahead, Jeremy.
9, 8, 6.
Wow. Guys, guess what? 9 plus 8 is 17, plus 6 more is 23. That is awesome. Again, 6 different ways. And finally, who can do 24? Now, Jeremy should have helped you guys to do 24. Raymond?
What?
Well, you raised your hand. I thought you raised your hand for 24.
I raised my hand for 24.
Then what are the 3 numbers, buddy?
I forgot.
Okay, can somebody help him out? Go ahead, Aaron.
7, 8, 9.
Of course, it's got to be 1 more than 6 because 24 is 1 more than 23. Now, guys, these are the easiest ones to do on Kakuru. Now, if we know that 6 and 7 have the fewest, and 23 and 24 have the fewest, which numbers can have the most possible numbers? What do you think it would be? Where do you think it would appear? Brennan.
14, 15, and 16.
14, 15, and 16 is correct. Those are the middle 3 numbers, and let's test it. Who wants to do 15 first? We're going to have 3 numbers that are going to make 15. Now, who wants to come up with all the different ways? And what I recommend is you start with a 1, you start with a 1, and you start with a 9 on the outside. So write those down. Write down a 1, separated a 9, and then what number has to go in the middle? On 3. 1, 2, 3.
5.
Wow. Now, put down a 1 again. But
9 and
instead
5.
of a 9, let's make it an 8. If we make the 9 an 8 and we keep the 1 a 1, what would this number have to be on 3? 1, 2, 3?
6.
Yes. And what if we kept it a 1 and made this a 7?
4.
Have to have a 7, but you can't do that.
Guys, we're not allowed to have 2 of the same. So we're not allowed to have any more where we start with the number 1. So of course, now we should start with the number 2. Let's do 2 and 9 again. So 2 and 9 make 11. And 11 plus what is 15?
4.
Good.
4.
Do it again. 2 and 8 needs a what?
5.
Go. 2 and 7 needs a
6.
now. Who thinks they know the next number that's going to go first?
3.
Yep. We are done with our 2s. Let's do our 3. Well, we start with our 9. And let's do it. 3 plus 9 plus
3.
uh-oh. Can't do that one. So guess what? We can't do 3 and 9. We're going to do 3 and
8.
and therefore 3 plus what plus 8?
4.
Hey, keep going, keep going. How about 3 and 7?
5.
Oh my gosh. What about 3 and 6?
6.
Uh-oh. Can't do that one. So we're going to take out those. What number should we start with next?
4.
4 and 9.
We needed 2.
Oh, wait a minute, guys. Don't we already have 2, 4, and 9?
Yes.
Right? So we're going to take out the 9. What about an 8?
We need a 3.
Don't we already have one of those?
Yes.
So what we can learn from this, guys, is that we have to have a number here that is bigger than 4. So 4 plus 5 plus what?
4. Wait, no.
No.
6.
And if you said 6, guys, how many different choices?
8.
8.
And guess what? Each and every one of them has 6 different ways. So we would have to do 6 times 8 is the number of ways we could put 15 in 3 spaces. Who thinks they could do 8 plus 8 plus 8 plus 8 plus 8 plus 8 6 times? Who thinks they could count by 8? Would you like to do it with me? Let's do it together, guys. Go.
8,
8,
8.
16,
16,
24,
24,
30.
32,
2.
30, no, 40,
40. One more.
48.
You did it. Guys, there are 48 different ways to make the number 15. Would you ever want to choose the number 15 if we had 3 in a row for 15?
No.
No way. Now, let's try the number 16. Remember, Brennan said that the number 16 would also have a lot of options. Let's see if he's right. Let's start out with 1 again and 9. Don't say it out loud. Don't say it out loud. On 3, give me the middle number. On 3, 1, 2, 3.
6.
Yes. Now we'll do 1 and 8. Go.
7.
Excellent. Now, should we go to 1 and 7?
No.
No, because that's the same. So let's move now to the number 2. 2 and 9.
6, 5,
Very good. 2 and 8.
6.
7, 7,
Well, if 2, 5, and 9 make 16, then 2, 8, and 6. Isn't 2 and 8 10? And isn't 10 plus 6 16? So you know it's got to be a 6. What about 2 and 7?
7.
Oh, are we allowed to have that one? No, take it out. All right, you guys do the next one on your own. You guys do the next one on your own. Write it out. Write it out, but don't say it out loud. Write out the next one, but don't say it out loud. And I'm going to call on the group in 1 second, or 2 seconds actually. So just wait, just wait. On 3, 1, 2, 3, go.
4,
Well, I need 3 numbers.
3, 4, 9.
Guess what, guys? 3, 4, and 9 is exactly right. and it makes 16. What about 3 and 8?
3, 8, 5.
And 5. Very good. What about 3 and 7?
6.
You guys do the next one on your own.
6.
4, 9, and 3.
Well, 4, 9, and 3 we already have, but that was a good one. Please do not call it out. Raise your hand. Everybody should be trying. I'm so excited, guys. You guys are amazing. All right, let's give it a shot. On 3. 1, 2, 3.
4, 8, and 3.
4, 8, and 3. 4, 8, and 3. Now, doesn't that make 15?
Oh, 4, 9, 3. But we already have it.
We already have that one. Did anybody try 4 and what? How about 4 and 5? Did anybody try 4 and 5? Remember, it has to be bigger than the first number. And what is 9 plus what is 16? You know this. It's 7. It is 7. And guess what? We are done. There are 8 different ways times 6. Who knows 8 times 6? Come on, guys. 8 times 6 is 48. That is right. Now, you guys could do the next one on your own. And the next one you're going to try is 14. And I want you to try to find all 8 different ways, all 8 combinations. So there are 8 combinations, and there are 48 permutations where we can change the order around. So I want you to do the combinations and then the permutations, and then have a lot of fun doing it. Well, do we feel like our brains are feeling good right now? If you do, put your hands up like this and stretch. Stretch really high into the sky and grab a couple of permutations. Grab a couple of permutations. Now grab a couple of combinations, and then let's smush them together and say, whoosh. We love permutations. And I will see you guys in just 167 hours, and I will be counting the minutes. I will be counting the minutes. Bye, guys.
Bye.
See ya. Bye.
Bye.
Bye, Tess. Bye, Brennan. Bye, Raymond.
Bye.
Bye, Avery.
Bye.
Bye, Tess.